Cloud. I love that. The cloud. Can you imagine telling somebody years ago, like, oh yeah, I like to put things in the cloud? People would be freaked out. They would not know what you're talking about. Anyway, what did we like about this problem? What did we find challenging? What did we find easy? What was patterns we thought about, recognized? Let's discuss, talk about.
So like where I sort of got stuck on was just sort of trying to figure out how I was going to make the comparison or what, not how, but like more so like what would be the best way. So I was just trying to figure out whether or not, like, like iterating and then like making comparisons over points. So, like it was not like tough, but I was still sort of figuring that out.
So what approach did you decide on in the end?
First, I ended up iterating first. First, I made a variable called reverse string, where it was just sort of like I split, then I reversed, and I joined. So I created sort of like a string to make a comparison to that second string. So like the first string would be the original string, and the second string would be the string that I'm comparing to see if it's an anagram. Then I basically did a check to see if that second string was equal to that reverse string, and I was trying to figure out what I would do with that first string now, I guess. So yeah.
Okay, cool. What else? Any other approaches that we had? We're awake though, yeah? I know we're awake. We all put 3s and 4s in the survey. All right, well, if nobody wants to talk, then I guess let's just keep going. All right, so let's go ahead and go through this. So, all right, this is our problem here, isAnagram. So we're trying to write a function that takes in 2 strings and determines whether those 2 strings are anagrams. So an anagram is a word, phrase, or name formed by rearranging the letters of another, such as cinema formed from iceman, right? So Elvis lives is another one of those. So we would expect true. Cinnamon iceman, we would expect true. Elvis loves, right? That's not an anagram. Elvis, 2 L's, lives, right? So that's also not an anagram. Why is that not an anagram? Anybody tell me that?
2 L's, 2 L's on Elvis and lives on lives 1 L.
Exactly, right? So let's think of some rules that we could come up with. So like when we're thinking about how we can solve this problem. So the rules. What is going to be our definition?
The length needs to be the same.
Okay. Length. I like that, right? Length must be the same on each string. Okay, right, because if it's not the same length, it cannot be an anagram. Okay. What else? What's another rule?
The letters must be like being the same in each string.
Okay, so must only have same letters. Okay. Do we have any other rules?
No extra of the same letters.
So what's another way of putting that?
No duplicates?
What?
No duplicates?
No duplicates. No, we can have duplicates.
You could have duplicates because
we need to have equal what? Of
equal length.
Well, we've got that taken care of here. Equal length of the string.
Equal amounts of
Equal occurrences.
Yeah, right. Equal occurrences, equal count, right? Exactly the same thing that Henry's saying is we can't have extra. I'm just trying to put it in. I'm just trying to frame it in a sentence that's going to push us more towards the right answer, right? So like each letters must have equal count or occurrence, right? I'll just say count in each string, right? So this tells us a lot, right? I will say this is a question I've asked in interviews. I'll tell you what. I'll just quickly show you some of the answers I get. string.1.split dot sort dot join equal to string.2.split dot sort dot join. Okay, will this work? Who thinks this will work?
I think it would, but it'd take a long time.
Tell me about
No.
that.
Oh, sorry.
Corey, I have a question. Can you sort strings?
You can't sort strings, but you can sort arrays. So that's why I'm splitting it.
Okay.
Good question. So let's go to node warm up. Okay, so we get true, true, false, false, false. So yeah, this works, right? So yeah, somebody said it takes a long time. I don't know who that was. Can you tell me how long it actually takes? Who can tell me the time complexity of this?
N log n.
Okay, yeah, so what was that, Maria?
Yeah.
That's pretty good, right? So whenever we're sorting, this is an n log n, right? This is n. This is n log n. Oops, something's going to change. This join is an n. That said, when we go to string 2, we have an n and an n log n and an n, right? So you might be tempted to say n log n, and you're almost right. But are we guaranteed right now that string 1 and string 2 are of equal length?
No.
So can we confidently for sure say this is n log n? So the actual time complexity of this is because we're not checking for length. If we did a length check, it's n log n, 100%. But because we're not checking for any length, these could be wildly different lengths. Therefore, we can only say n log n plus m log m. Right? So as this is, it's n log n plus m log m. No, that's being really like persnickety about time, right? But this is the correct time. I mean, we have no guarantee right now that they're the same lengths, and we're still splitting and sorting. So as either one of these could approach infinity, so these are not a constant. I could easily mitigate that risk, right? Just saying if string 1 dot length does not equal string 2 dot length, return false, right? Just like that, we can remove one whole m log m, right? Now we're right with what Maria originally said, n log n, right? Because now we've taken away that variance of size. Okay. Any questions on this so far? Okay. So, like I said, this is definitely an answer I've gotten a couple times in different interviews. And it's like, all right, yeah, congratulations. You solved it in 15 seconds with the built-in methods. What's the time complexity? Some of them don't know. And it's like, all right, well, this is kind of slow. Is there a way we can do this faster? And a lot of those answers for those people were no. They were unable to. And then it was an awkward 40 rest of the minutes. But you know, we nudged and we talked. It was all good. Not really trying to throw shade on them. They were all great people. It just wasn't the right fit for the job. That said, right, this is still an important thing to talk about, right? I know that in those rubrics that from our technical interviews, right, it's coming up with multiple high-level approaches, right? You don't actually have to solve this, but it's okay to mention, well, I could just split and sort the strings and join them and compare them. Would you like me to do that, or would you like me to find a more efficient way of solving this problem, right? That's okay. It's good to acknowledge that you know that you could just do this. That's a good thing. And it doesn't hurt to talk about a slower solution just so they're aware that you also know that and think about that. You want to show that you can solve a problem multiple ways, or at least through conversation, right? You don't actually have to code this, although it takes all of 2 minutes, right? So I'm just gonna comment that out over here though, because we're not really interested in that solution. Instead, we want to abide by these rules. So the first rule is being taken care of here. Cool. Must only have same characters, and letters must have equal count in each string. So if we're thinking about equal count in each string, what's a pattern that comes to mind that may help us?
Maybe creating a counting object.
Yeah, an accounting object, an occurrence count. I pretty much always make these as a helper function, so I'm going to go ahead and do that. Const occurrence. I probably already have one in here. I'm going to call it counter for now. And this takes in a string. And so I can't use like reduce here because it's a string, and I could split it, but that just seems like a waste of a loop. So I am just going to iterate it through as a string. So we'll just say const output, or I'll call it counts. It's equal to our object, and we can do a for let character string loop, and then we can just do our checks here. So counts at character. So if we have that counts a character, let's go ahead and just increment the count. Otherwise, counts of character, we'll assign that to 1. And at the end, we'll return our counts. Okay, so just for fun, let's go ahead and call this on the first string. So let's say let string 1 counts equal to counter of string 1, and let's go ahead and just test that. So we'll say string 1 counts. Oops. Counts. So let's make sure we're seeing the right counts. Let's just do it for the first one. Let's not get too crazy. Okay. Okay, we got an error. What's the error? Counter has already been declared. So that's I probably made something. I already did that with socks without pair. Well, okay. That's annoying. All right, so counter of string. All right. Right, totally reusable function. We could use that other function. We can make it a little bit more flexible so that it takes in an array or a string. Okay, so we see E is 1, L is 1, V. All right, so this is seemingly working. Let's just add another L in here to make sure that it works with multiple duplicates. I don't know.
Length.
Oh, yeah, thanks. We didn't get to that part. Okay, so L became a count of 2 that time. All right, great. So things are working. Our counts works. Okay, so now we've got, so now just so you know, you can do different things in different languages. If I was building this in Ruby, I would go like this. String 2, and then I would say return string 1 counts equal to string 2 counts. Okay, and this, I actually was asked this question also in an interview for this job, and this is how I solved it. Will this work?
Yeah.
Yeah? Why?
Because it won't return if it's not equal. Wait, but it's gonna return false if they're not the same length, and then it's gonna return true if it is.
Okay. Oh, let me fix this. Yes.
I think it'll still be false because I think it's like arrays. Like if they're from a copy of the same thing, then they would be equal, but they're not a copy of the same thing, so it'll be false.
Okay. In the participants tab, give me a yes for this will work and a no for this will not work. Okay, so I'm seeing a lot more no's. So Fowler said no because he said it's like arrays and a copy. Can anybody tell me a little bit more on that answer? Like, why?
Isn't it that they're pointed to an exact address or something? So
Keep going.
so string 1 counts points to one address and string 2 counts points to a different address. So if they're not pointed to the same address, then they're not the same, basically.
Exactly. Right. So let's go back to our node here, right? If I have an object where I have A pointing to 1 equal to B pointing to A pointing to 1, almost made no, right? This still comes up as false, even though these are identical to our eyes. Now there are, and this is exactly as Doug said, right? These are pointing to an address. JavaScript is doing a comparison for objects, which arrays are also objects, so that's why it's the same thing with arrays, of address or ID, but they're not comparing the actual elements inside. There are libraries that would allow me to do something like this, like Lodash would be one of those, probably underscore as well, but I'd have to add like Lodash. It looks like this. There's probably something for object comparison. In some languages, this is built in, right? So in Ruby, so when I was first applying for this job and had this interview, Ruby, I was way more comfortable in Ruby than JavaScript. And so this is how I solved it, because this is how I would solve it in Ruby. I had converted it in my head, and this would work in Ruby. So that's part of like knowing the tool that you have, right? Because if I would have written it in Ruby, I would have been correct. But because I wrote it in JavaScript, I was actually incorrect. My interviewer at the time was only familiar with really Java. They didn't know JavaScript, so I think they were also convinced that I was correct, because I didn't know I was lying at the time, so I was very convincing. So, I mean, I got the job, right? A little bit after that. But I went home that night and checked my work, and I just started sweating like crazy. And I was like, I really hope that that Java developer really didn't know much about JavaScript, because if he did, I'm screwed. So this works not in JavaScript. Too bad. But it does work in Ruby. Okay, so let's think of a different way. Do we really need the second object? So maybe we don't, right? Because maybe we can iterate through the first object again and decrement every time, right? So let's say I iterated through our string 2. So I said for let character of string 2. So this time I'm going through our string 2. Now I could say, hey, if string 1 counts dot character. So what would I want to do? If I have this character, what would that mean? What should I do?
Decrement by 1.
Yeah, right, because I want to get this closer. Right? So I'll say, if that's the case, string 1 counts at character minus minus. Now, else, what if string 1 counts doesn't have this? What would that mean?
False.
Sorry?
You want to return false?
Yeah, right? Because this means one of two things. Either this is giving me back undefined, which means string 1 didn't have that, so that can't be an anagram. Or the count of this is already 0, and this is expecting to have one more. So if that's the case, I can just return false. Okay. And that's okay. And then at the very end, you might say, "What? So what's left? What's left to do? What is there anything else we need to do?"
Check if there are any. If there's anything left inside?
Ah, okay. I was hoping someone would say that. Right. So Tyler says we should check to see if all values of the keys are 0, essentially. Now, this is kind of like a little brain teaser. Is that necessary? If the lengths are equal, because we checked the lengths at the top, is it possible for us to have gone all the way through without returning false and not have an anagram?
I think so.
Okay, because I don't think so. Let's talk about it. Let's see. I could be wrong. So let's actually develop this together here, right? So let's say we had Elvis, right? We'll go back to Elvis. So E, what's that? E points to 1. E points to 1. L points to 1. V points to 1. I points to 1. And S points to 1. Okay. So let's see how we can prove this. So we have lives. So we know that lives will work, right? It would decrement each one, and we would get through, and we know that that's an anagram. So there's not really a need to test if everything is 0 at the end. So my question is, what's an input that I can put in that's going to leave something left over by the time we get through to the end?
Loves.
Loves. Okay. So we go loves. I like that. Challenge accepted. We get the L. L gets decremented to 0. We have O. O does not exist. We return false. All right. Let's go back. So loves works. Let's try another. What else could we try? Maybe we try 2 L's.
Yeah, I was gonna say that.
And I'll just drop the I or something. Okay, we go to L. This gets decremented to 0. We go to the next L. We key into this. This gives us back a 0. 0 is a falsy term. So we don't get the decrement again. Instead, we return false. And that's the end of that one. Any other? I know it's a weird jump, but the jump really has to happen only because we're checking for length. If we didn't check for length, we would be doing extra iterations, but then there would be the risk.
No, I think you covered everything.
Okay. I've convinced you, Henry?
Yeah.
Is anybody else left unconvinced still? It's okay if you are. Like, we can talk about it. That's fun. I got the job again. Thanks, Doug. Well, I answered it wrong the first time. Really. I did if I had only written in Ruby. The interviewer really didn't know Ruby. I should have written that in it. Okay, so then we can just return true. So this is a pretty good answer. I don't know if we can get to a better one. I haven't figured it out yet. There may be one though. There's probably something with like regex, which is pretty sick, but it might be longer in time complexity. Okay, so we go to warm up and we get all of the correct answers. So what is the time complexity of this? Okay, Nilbert, thank you for answering. Doug, thank you. Marva, thanks. Yeah, right. This is linear because we are going through every single word character one time. It's going to grow as our input approaches infinity, but it is only n. How about space complexity? What is the space complexity of this? Siham, what's CST? Doug says linear. Oh, I gotcha. Thank you, Siham. Thanks, Marvin, Nilver. So yeah, this is actually going to be linear, right? So the reason this is linear is because we are creating this counter object here. And that object is going to grow. The amount of things we're going to have to store potentially grows with the string, with the size of the string. Now Siam says constant, which is kind of interesting. And I'll say that there is an argument to be made that this is constant. And this is something that you can talk about with your interviewer too, right? The reason this could be constant is because like we could talk about what kind of characters are going to be added, right? Like, I mean, if it's characters of every language all over the place, yeah, maybe it's linear. But if they just said this is the English alphabet, well, if this is just the English alphabet, that's 26 characters, right? So that's constant because we know our object is only going to be 26 keys long. Does that make sense? So if that's the case, there can be an argument made constant. So thanks, Siham, for bringing that up. But so that kind of just depends on your standpoint of what the different things coming in are going to be. It could be linear in some senses if you look at it that way, but it also could be constant if you look at it another way. I will say there's something we're not really accounting for, which we definitely should have talked about with our interviewer, which is like handling spaces and also capitalization, right? Does casing matter in this, right? Is Elvis lives, should this give us true or false, right? That's an important question to ask. So if this is supposed to return true, our answer no longer works, right? Because now, that's the first one here. They have different characters. So if we wanted to make this a little bit more sensitive, we could just say like string.to lowercase. And we could say .to lowercase where we're looping, right? And then we get our answer back, right? So that's possible. That's like a quick adjustment, but it is something that you should ask about in an interview. Trying to think if I'm missing anything. Oh, I saw a question a little earlier from Ajwaka Basi asking about vials. So vials is a acronym. So that would have returned true. which is what we would want. This was when we were trying to come up with cases that wouldn't work.
Okay, I was just a little bit confused because I thought like it had to match, like when you're doing the decrement, I thought it had to like match the order going backwards. So I was just trying to figure out if like that mattered or not.
Oh, great.
Yeah.
Yeah. So that shouldn't matter. The objects aren't supposed to be inherently ordered. They should be,
Okay.
you should never have to be counting on the order of an object.
Okay.
That's, I mean, they do make ones that are like connected by the order you put them in, but ideally you're not relying on the order of an object. So it shouldn't really matter as long as we know the length and the values are gonna come towards 0.
Okay. All right. Thank you.
No problem. Great question. Any other questions or anything about this problem that anybody wants to talk about?
How would you handle spacing? Would you eliminate it from the start, or would you somehow check for it in the second function?
So you're asking that the interviewer doesn't want spaces to be part of the sentence, right? You want me to ignore spaces?
Yeah.
So if that were the case, I would have just had an extra if statement, like probably in both of these, but I would just say like, hey, if my character is equal to that, just continue. That should work for both of these. Let's go ahead and try. So I'll say Elvis lives. Oh, not working.
You still have.
I spelled what?
Never mind.
Is it because you have 2 spaces in lives and 1 space in Elvis?
Yeah, right. But we're saying we would want that to be true, right? Because we want it to ignore the.
Yeah, but the lengths would be different now.
Oh, but the lengths would be different. Oh, that's. So if that was the case, we would no longer. Well, if we're trying to ignore spaces, we no longer could test for length. Potentially. So now we would maybe comment this out. Just want to see, this should return true, but should return true without being actually safe, right? Because now we would have to check if each value is a 0. So now we could just say instead, so this is us ignoring spaces, I could just say object.values, and we could say string 1 counts. So this should give me all the values that are left over. And then I would say every, I'm going to return whatever I get back here, element, and I would say element equal to 0. And so now this should return true still. So this is kind of the check that Fowler was originally talking about, which we didn't need when we weren't worried about having spaces. That's a great point, Doug. Thank you for bringing that up. And nice catch, Isaiah, always watching that length. It's like the second time you've caught me on the length of why the example's not working. Any questions on that alteration? All right. Well, great job, everybody. I'm going to stop the share. I'm going to stop recording. I'll push these notes